Okay, for number 2, find all complex numbers which satisfy this equation. And just to remind you, complex numbers are the form A plus BI. All right? So let's go to the whiteboard again. And I'm going to write the equation down. And let's take a look. You get x minus 1 to the 5th power equals x5 minus 1. By the way, I see, excuse me, I do see one clear solution to the problem, and that's the number 1, right? Because 1 minus 1 is 0, and 0 to 5 is 0, and 1 minus 1 is 0. So I'll write it down as a complex number. It's 1 plus 0I. All right, that's one root. And what I want to do is I want to expand it. All right, because I'm wondering, there's going to be 5 of these things. I have to find 4 more. So this is going to be x5. I'm using the binomial theorem to expand it, by the way. 5x4. Maybe I should go through with that trees for you. Now, I'll erase it though. 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. I'll erase that in a moment, by the way. So the next term is going to be plus 10x cubed minus 10x squared plus 5x minus 1 is equal to x5 minus 1. Let me just take a look at that before I proceed forward to make sure I did okay with the multiplication. You know, I'm looking at the coefficients, plus minus, plus minus, plus minus. That looks good. And then you're getting 1, 5, 10, and 1, 5, 10. Let's look at the powers. 5, 4, 3, 2, 1, none. Looks good. What I'm going to do now, I'm going to subtract x5 from both sides. All right? And I'm going to add 1 to both sides. And what do you get? You get minus 5x4 plus 10x cubed minus 10x squared plus 5x equals 0. All right? So then someone says, what are you going to do about that? Well, I have, like, I'm going to factor it. I'm going to factor out that, I guess, the GCF, right? So I'm going to say minus 5x. And again, I hope I'm not going so fast you can't do that. And I'm going to look at that now. And what would you get there? Let's take a look at that. You get x cubed minus 2x squared plus 2x. And then what would I get there? I would get, let's see, minus 1, right? Equals 0. I got another solution over here. I'll write down for you. X equals 0 plus 0I. Right, now I got 3 more to go. And I'm looking at it. And I got x cubed minus 2x squared plus 2x minus 1. And I'm wondering when this becomes 0. I'm kind of looking at it. And I'm going to say, looking at it, I got to do something with that, right? I'm going to look at that. It got really nice symmetry to it. I'm going to guess another root now. I'm going to say I'm going to guess the root 1 now, just for this guy here. Let's just check it out. What do you get? 1 minus 2 plus 2 minus 1. I got another root. Let's write that down. X equals, that would be 1 plus 0I. All right? Now, so how are you going to get the other roots? Well, I'm going to work with that knowledge now to get 2 more roots. And what I'm going to do is long divide that cubic polynomial by the factor that produced the root 1. Let's put this down. X cubed minus 2x squared plus 2x minus 1. And we're going to divide this. Again, the root that produced this was 1, so that means the factor would be x minus 1. What are you going to do now? Multiply. What times x gives you x cubed? X squared. What do you get there? You get x cubed minus x squared. You're going to subtract minus x squared plus 2x minus 1. By the way, the remainder theorem says the remainder is going to be 0, but let's hope we don't make any mistakes, by the way. Minus x, what do you get there? Minus x squared. Let's see, plus x. Subtract, you get x minus 1. Well, plus 1, what do you get there? X minus 1, remainder 0. All right? So I got my 3 roots. I'm going to go for the next 2. And what I'm going to do that is look at that quadratic. I can't factor it, so I have to use a quadratic formula. Let's write that down. X equals, let's see, 2, 1, plus or minus. And what do you get there? Let's see, b squared would be 1, minus 4 times 1 times 1 is 4. So you get x equals 1 plus or minus the square root of minus 3. On the bottom you get 2. Let me keep on with this one because I have to write down as a complex number, right? So 1 plus or minus, this is going to be I root 3 over 2. So I'm going to write the 2 answers down now. X equals 1/2 plus root 3 over 2I. And the other one's going to be x equals 1/2 minus root 3 over 2I. And we found all 5 roots, by the way. Let me go back and look at the actual question now. Find all complex numbers which satisfy the equation. And we did, and we found them all. My problem with this over here is that, listing them out, I think I had to write these down to move my way forward in the problem. And I think we did okay there. And again, let me just count them up. And yeah, I got them all counted up. And these occur in conjugate pair. That's a good idea. I'm seeing this as a repeated root, and I'm seeing this really has really simple roots, trivial almost. All right, thank you.